Hi, my name is Megan Slakel, and I'm presenting on sites next to the Nesbits and next to the land next to Nesbits. So this is Nesbits, and this is the land next to Nesbits. So the layout is, of course, I showed you Nesbit, which is a building right over here, and it has a hill going down. And this is the batch of land, and in this last picture, you can see the pond, which is right there. I'm presenting on all of that. Nesbit is mostly used for language classes and some others, but there is also a coffee shop there, which is Starbucks. It also has a few study rooms. The land is used for nothing on a regular basis, but sometimes we hold events there, and there's also places to sit between Nesbit and the land. What is done right at Nesbit? The building takes up a lot less space because it has floors instead of going all the way out, which is an example like UGA did with their buildings, reducing the land footprint. But UGA had to do it because they were landlocked, and going up before we are landlocked is a better way of making sure that we have enough land in the future for other buildings we want to make. Nesbit also recycles. Everywhere you walk, there's going to be a recycling bin on Nesbit. Like, I can't turn around without seeing one. And the land is mostly untouched on a regular basis, besides those events I mentioned. And it remains in a grassy state for all the insects or other animals that need that habitat in the grassy state. So for the land sides, we can open up the connecting pond to the area right below the hill of Nesbit and make a stream. We can make an improvement on the impervious runoff areas, which can go into the stream. And then the stages of that would be digging a canal or stream to the current pond and going as far to dig another pond connecting to the bigger pond, which is connecting the streams. And this is my little drawing I tried to draw. Not very good at it, sorry. So this is Nesbit, and then over here's the pond, but you can make a stream going from the hill because it's hill, so it'd be easy to make a stream going all the way to the pond. And then this is I drew the extra pond and the stream connecting to the other pond as a backup plan. Stage 2 is making a plan of where all the impervious runoff areas need to be improved on campus. So everywhere on campus, when it floods, you always step in puddles, and it's like a mini pond or flood of its own, and it's very annoying, and I can never walk in the rain without my feet getting soaked. And then stage 3 is laying a drainage system out from the key areas on campus that it mostly floods to get to the pond or stream to fill it up. This way, the underground, if it's underground, it does not mess with habitats for very much or very long if it does at all. Yes. The cons or pros of this might be a little more costly than we wanted, but in the long run, it'll save the earth. And, you want to save the earth because without that, then we have nowhere to live. And you also might save habitats because flooding is not good for habitats either. And the drainage system going under makes more water areas for those habitats to have so they don't run out of habitat area space. And a pro, I guess that would also be a pro. When it rains, the sidewalk becomes flooded, like I mentioned. Everywhere you step is a mini pond of its own. How would the land side help us? It would create other environments, like I already mentioned, but it creates an environment for the scientific department to have a chance of improving area around for practical lab uses, providing more space for fish and animals to live. It is a natural habitat for the students to take care of it, and it'll also be good for irrigation, have more gardens and greenhouses. It's also pretty. You love pretty landscapes, everyone does, and you could also add more trees or plants to make the habitat bigger and more scientific. So the shed for Nesbit. Nesbit already has a lot of sets, like I mentioned, the recycling and everything, but we could turn this into specifically environmental science department for the school, it could be a project. You take it one floor at a time per year, implementing energy sources or saving devices on each floor to calculate how the energy works and the savings you would get per year. And each year you can add a floor to see the difference between each floor. And then at the end of the 5th year, you could do the cost-benefit analysis at the end. And that would show how much we save. You could also use different buildings. If you don't want to do a 5-story building, go to a 2-story building like the science building. Some of those energy-saving devices would be LED bulbs, motion sensor lights, energy-deficient windows and doors, solar panels on the roof near the building to measure the cost efficiency, waterless toilets, and automatic faucets. And this is a picture. It was just the high-efficiency toilets versus regular toilets, and it has dates of 1922, regular, and high-efficiency gallons per flush. The pros and cons would take time, but it would be worth it. The con, it might be a little more cost efficient, might cost a little more than you wanted, but in the long term, it would be worth it because it helps our planet and our lives. Now, that is the end of my PowerPoint, and I think this is give you guys a lot to think about. Bye.